This is question number 7 of exercise 5.1 from the chapter Continuity and Differentiability. The question is, find all the points of discontinuity of f, where f is defined by fx is equal to modulus of x plus 3 if x is less than equal to minus 3. It is equal to minus 2x if x lies in the interval minus 3 to 3, and fx is equal to 6x plus 2 if x is greater than equal to 3. Okay, so now to solve this question, first of all we are going to check the continuity of the function in the intervals x is less than minus 3, x is greater than minus 3, less than 3, and x is greater than 3, and also for the points x is equal to minus 3 and x is equal to 3. Okay, now before that we have to simplify this function. And why? Because this modulus of x is given to us. So this function can be simplified as equal to these two terms will remain as it is because they cannot be simplified further, and fx is equal to modulus of x plus 3 is equal to minus of x plus 3. This is simplified as equal to minus of x plus 3. And why it has been done? Because the modulus function always gives a positive value. Okay, that we know. And because x is always negative, so this modulus function, to make the value positive, is going to multiply this with minus sign. Okay, and therefore modulus of x should be written as minus x. Okay, so hence in this manner we are going to simplify modulus of x is equal to minus x, so that the value always remains positive. Now in first case we are going to consider that x is less than minus 3. So for this we consider that c be any real number and c is less than minus 3. Okay, so limit of x tends to c for fx would be equal to limit of x tends to c for minus x plus 3, because in this interval fx is equal to minus x plus 3, and this would be equal to, on applying limits, this would be equal to minus c plus 3, and f of c is equal to minus c plus 3. That is the value of this function at x is equal to c. When c is less than minus 3, this would be equal to minus c plus 3. So this means that the limit of function when x tends to c is equal to f of c. Hence f is continuous for all numbers less than minus 3, that is f is continuous in the interval x less than minus 3. Okay, now we are going to consider the second case when x is equal to minus 3. And because we have to check the continuity of this function at this point, so we are going to take the left hand limit and the right hand limit of the function at this point. Okay, so f will be continuous at x is equal to minus 3 if left hand limit is equal to right hand limit is equal to the value of the function at minus 3. Okay, so limit of x tends to minus 3 negative of fx, that is the left hand limit, would be equal to limit of h tends to 0 of f of minus 3 minus h. Okay, and limit of x tends to minus 3 negative means that we are going to calculate the value of the function at the point minus 3 minus h, and which is the value less than minus 3. Okay, so therefore we are going to place minus 3 minus h in minus x plus 3, and this would be equal to limit of h tends to 0 of minus 3 minus h plus 3, and this simplifies to give me equal to a value 6. And similarly limit of x tends to minus 3 positive of fx would be equal to limit of h tends to 0 of minus 3 plus h, and this would be equal to limit of h tends to 0 of minus 2 into minus 3 plus h, and this would be equal to minus 2 into minus 3 plus 0 or 6. And f of minus 3 would be equal to minus of minus 3 plus 0 plus 3, that will be equal to 6. Therefore we get the left hand limit of the function is equal to the right hand limit of the function is equal to the value of the function at x is equal to minus 3. Okay, so therefore the function is continuous at minus 3. Now we are going to take the third case when x lies in the interval minus 3 to 3, or x is greater than minus 3 and less than 3. So let c be any real number and c lies in this interval. So limit of x tends to c for this function fx would be equal to limit of x tends to c of minus 2x, and this would be equal to minus 2c, and the value of the function at any point c in this interval would be equal to minus 2c. Therefore, limit of x tends to c for this function fx would be equal to f of c would be equal to minus 2c, and c can be any value in this interval. Therefore, fx is continuous for all x belongs to minus 3 to 3, that is for all values of the x greater than minus 3 and less than 3. Again, we are going to take the fourth case in which x is equal to 3, and for this we are going to first of all calculate the left hand limit and right hand limit when x tends to 3. So limit of x tends to 3 negative, that is the left hand limit of this function, would be at x is equal to 3 would be equal to limit of h tends to 0 of f of 3 minus h. So 3 minus h is a value less than 3. Okay, so we are going to take this value for fx, that is minus 2x. So limit of h tends to 0 of minus 2 of 3 minus h, and this would be equal to minus 2 into 3 minus 0 on applying limits, and this would be equal to minus 6. And similarly, the right hand limit, that is the limit of x tends to 3 positive of fx, would be equal to limit of h tends to 0 of f of 3 plus h, and this would be equal to limit of h tends to 0 of 6 into 3 plus h plus 2, because this function f would take the value 6x plus 2 when x is greater than 3. So this would be equal to, on applying limits, 6 into 3 plus 0 plus 2, or this would be equal to 20. Okay, 18 plus 2, 20. So left hand limit is unequal to right hand limit when x tends to 3. Therefore, the function is not continuous at x is equal to 3. Okay, now we are going to consider the fifth case when x is greater than 3. So it is very simple. Let c be any real number, x is greater than 3. So limit of x tends to c for fx would be equal to limit of x tends to c for 6x plus 2, because fx is going to take the value 6x plus 2 when we are going to take any value greater than or equal to 3. So this would be equal to 6c plus 2. And f of c again would be equal to 6c plus 2. Therefore, the limit of this function fx when x tends to c is equal to f of c, and c can be any value greater than or equal to 3. So f is continuous for all real numbers greater than 3. Hence f is continuous for all real number except 3. So 3 is the only point of discontinuity for this function, which is the required answer. Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.